computing should be done then and there itself, because one point about drones is that they are real time, meaning every activity must be done within specific response time. 1 second, half a second, 1 millisecond kind of time. Time is designed. Everything, come what may, has to happen within that limited time. That is why they are called as real-time systems, meaning within specified time period, the whole of the operation must be done, otherwise the whole thing will collapse. Other than for example, aircrafts or any other flying one, there is no time requirement. A specific serious time requirement is not there. Time can change. Suppose you want to go to San Francisco from here, it may take 15 hours, 16 hours, 17 hours, doesn't make any difference there. But in drone, real response time requirements will come into the picture. So when we design any drone, the time part is the most important thing, and that has to be taken into account. So onboard computers are required to do the computing then and there itself. It cannot wait to send the data, get processed on the ground station, get the outcome, and get command back onto the drone, and then drone will do the necessary required operation. There is no time because of the real-time requirements. Computing has to be done on the board itself. So different kinds of onboard computers are sometimes installed on top within the architecture of the drone system. Of course, telemetry system is required because commands are to go, commands are to be obeyed, commands are to be executed. Entire operation of the drone must be done in accordance with that particular command. Commands are either given through the handset or given through a ground station. Ground station is also again a big computing mechanism which communicates with the, for example, our rover on the moon, no individual, no human being is giving any command. It is a computing system which is programmed and available on the ground station, continuously keeps receiving data from the rover and gives commands to the rover to what to do. But rover is a stationary object, that is a different thing. Our drone is not stationary, it is a flying object. It keeps flying, flying, flying till it dies or comes back to the ground station. Those are the differences between them. And again, collision avoidance sensors. Drones generally enters into collisions because there are so many other flying object creatures, birds or other flying objects are there. If it goes and hits them, the drone will be dead. So drone should have an intelligence of the various possible collisions that might happen, and it should be able to object detection, one mechanism, using cameras of course, and immediately once it recognizes that there is an object, then it has to change its orientation. The longitude and latitude of the object must be known. Its own longitude, latitude it knows, then it does the maneuvering and changes the direction so that it doesn't hit that particular object. So there are connectivity modules like Wi-Fi, Bluetooth, collision avoidance sensors, they are called LiDAR or ultrasonic sensors. How do you know whether there is an object before you? Then there is a sensor called as ultrasonic sensor. It generates signals, ultrasonic signals, and if there is an object, those signals will go and hit that object and reflect back, and it receives the reflected signals. Then based on, once it receives, it knows that at so and so distance there is an object, and therefore it knows the location of that, so it changes its maneuvering. So drones are generally affected due to the obstacles. While it is flying, it has to take the knowledge about various other objects, and the fellow who is there on the ground has no knowledge about what is there around the drone which is happening right there. So the drones are expected to know those barriers, identify the exact location of them, and then take automatic maneuvering mechanism so that it doesn't go and hit that. There are a lot of embedded boards used. I have given the different types of embedded boards we used in the drones. For flight controller, PixVac series, then DJI Naja series, Open Pilot Revolution. There are so many microcontrollers and micro boards which are being manufactured all over the world, specifically looking at different aspects of the flights. Okay. Similarly, microcontroller, STM32 we are also using here, Raspberry Pi, then NVIDIA, which is the graphical processing systems, which are very faster in nature. And these are there are different kinds of controllers which are being used for different purposes within the drone itself. In a drone, a typical drone can have one or more than one microcontroller, sometimes 4, 5, 6, 7, depending on the type of drone which you are actually suggesting. Companion computers also will be there. Sometimes, if the computing is very much required, putting a computer on board for doing computing is difficult, then a separate computer which is there on Earth station is situated, data is sent, and the computer processes them and sends the results back. Such kind of computers are called as companion computers. That is also one. You have communication modules, you have GPS module. These are all the various hardware components that can be. There is what is called as sensor integration boards. Nowadays, about 3 or 4 parameters are required. All 3-4 parameters have different devices. You integrate them and bring out to a single board and position that single board within the total system of the drone in the main system. Sensor integration, for example, inertial measurement units is an integrated sensor board which actually combines the acceleration and gyroscope. What is gyroscope? Anybody in the class? Do you know what is gyroscope? The one which will tell you the direction, north, south, east, west, in which direction are we flying, in which angle are we flying, what is the sequence of longitude, latitudes that it has traveled. All these things can be obtained through a gyro. Generally, it is direction in which the drone is moving. Of course, you have camera interface boards, you have video interface boards, depending on the type of function that you have, that we have designed the drone to do. The respective modules are collected and interfaced with the main logic. One important thing about drones is, I already told you, drones have to work in real time. Within a specified period of time, the responses must be completed. There is no, flexibility for us to delay an operation or, do it at a little later date. This kind of mechanisms are not allowed in the drone. Therefore, if you want the firmware or the software which is installed in different microcontrollers to be executed, you need what is called as real-time operating systems. Operating systems which will allow you to do the operations in real time. Real time means any time which is designed for that particular drone. So I have collected information about what kind of real-time operating systems are being used in different microcontrollers, and I have listed down NetX, PX4, NetX, free RTOS for AMD processors, CB, OS RT, RTOS for Linux. So many real-time operating systems are there, which are being used in different microcontrollers, which are used for developing the drones. And for each, based on the purpose of the drone, a specific type of RTOS is selected. Without RTOS, there is no real-time operating system. The operating system gives different functions which actually are required to complete a given task within a specified period of time. That is what is called as real-time. Of course, you are learning operating system, but they are regular operating systems which are put into the controller computing system in order to optimally use all the resources available in the computers. Here it is, the functioning is about real-time. Ability to complete the task execution within specified amount of time. How much is the time and all that, it is a different issue. We need to look at it from the design angle. As I said, one of the most important thing is what are the different sensors and what are the different actuators which are used in the drone, Obviously, the first one is the interstitial measurement, which is global positioning system. Barometer. Why barometer? What does the barometer do? Barometer will measure the pressure that is exerted on the drone while it is flying. Okay, pressure, and help drones estimate altitude. What is the altitude at which the drone is moving is based on the pressure. So as the drone goes up, the pressure depletes. The lesser generally people will think when we go up, the pressure is going to increase, but that is not the case. Ozone layers depletes as we go up. Therefore, pressure exerted is directly equal to the altitude at which the drone is moving. So there are barometers which are installed on top of within the drones, so that you keep on measuring the pressure, and from pressure you estimate what is the altitude at which it is running, and the altitude is transmitted back to the ground station. So it is worthwhile to know all kinds of sensors and actuators and the purpose for which they are to be made available and put into the drone system. As from the hardware point of view, once you decide on hardware, obviously the firmware also will come into picture. Then we will, using RTOS, that firmware has to be developed. There is a compass also, because measure the strength and direction of the magnetic field. See, another important issue about drone is magnetic field. Okay, if you don't measure the magnetic field, and again magnetic field is being used to transmit power from one machine to the other. I don't know how many of you knows about NFC, near field communication. NFC is one mechanism where power in one drone is transmitted to another drone. Therefore, one drone can be made to move to any longer distance. That is called as NFC. So identifying how much is the magnetic field around a particular drone at that point of time is equally important. That also helps you to determine the barriers, obstacles that are there while moving in the air. You have electrons, ultrasonic and LIDAR sensors. They are meant for obstacle avoidance and altitude control. These sensors are there for different particular purposes. They are all integrated through integrated modules into the system. Radars are also there to detect the existence of the objects, and based on that you will be able to trace how many objects are there around that particular drone. Drones are being used in defense to fire out, to shell bombs, to hit the targets, to release the laser rays, to anti-aircraft bombs are to be shelled down. For different purposes, drones are being used today. For every purpose, a drone is being designed. So it needs to know what is the magnetic field. It knows what is the visibility. It knows to know the navigation. It knows to know how to do the contouring so as to move to a particular spot and bomb that particular area. Gyroscopes and accelerometer sensors are also required to understand what is the speed at which the thing is moving. Gyrometers to know the direction. So now, I wanted to give you a little bit on what is drone, what exactly the hardware going to be there, what kind of sensors are there, what kind of actuators are there, what kind of microcontrollers are used within the drone. Idea is, the reason why I wanted to cover all of them is to know what exactly is the limitation of the drone. So one limitation is distance of travel is limited. If you want to enhance the distance, what do? That is a problem. Operation is limited by battery power. It is driven by battery. So what do? It limits the number of hours of operation that a drone can do, because there is a battery is the issue. Heterogeneity in communication systems. While one is built with UV4 and another one is built with Wi-Fi, how do they talk to each other? How is the communication going to do? How exactly the drones will be able to adapt itself so that they are able to communicate with each other. Inter-drone communication is needed to cover longer distances. needs a real-time response. This is another limitation. Anything you want to do must be done within specified time. If you don't do it, the whole operation will collapse. That is one of the most important requirement of any drone, and these are the limitations. And looking at these limitations, we need to, design a particular, looking at the application, you need to design the drone. Now, coming to our topic, what is evolution? I already told you in the beginning, ability to adapt to the changing situation. So what exactly are the things that are going to change? Why do the things change? What exactly is going to be changed? And when such change happens, what do we do? How do we adapt to such kind of changes is the actual topic that I wanted to talk. Oh, 10-15 minutes. No. Okay. So, we will look into dynamic evaluation. There are 4 different areas of dynamic evaluation. One is called as syntax evaluation. Second one is semantic. Third one is ability to test the changed or added software online while the drone is operational. The fourth evaluation is changing the communication system dynamically. Now, a drone is designed with some command language, okay, and another drone is designed with another command language, and these two command languages are different, and command languages keep changing for various reasons. Versions are different, and older version, suppose same command language with version V1 has to talk to version V2. We want to add more commands while the drone is running based on the amount of data that we get. How do we add more commands to the system? How do we adapt to different versions of the commands? And the ability of a drone to adjust itself for changed environment by way of adding commands, subtracting commands, or changing the versions of the command is called as dynamic evaluation, syntax evaluation. It is a command language evolution is called as syntax evaluation. Drones must be designed such that you will be able to add more commands while it is running. And if you want certain commands should not be executed, you should be able to do that. If you want one version of a command to talk with another version of the command, we should be able to do it. One command language should be able to talk to another command language. That is, suppose I just now told somebody is Tamil, somebody is Telugu. They want to talk. This command language is different. This command language is different. We need to get an interfacing between them. What do we do? How do we build the system so that evaluation is possible from the command language, syntax language? Syntax is all about command language. Semantic evaluation is, suppose there is a software available while running and the software is throwing errors. What do you do? Already drone is there in the field and it is reporting that rover is there on the moon, it is reporting some error is there. So the system should be designed in such a way that the false software has to be dropped, and a new software has to be sent to there, and that software should be made to work dynamically. That is called as the semantic evaluation. See, whenever you want to change the software, without testing you cannot change the software. What is the guarantee that this new software that you are sending is going to work? So there is an online testing to be done parallelly while the drone is in operation, and only when the testing is perfect and clear, then the new software should be made to run on top of the drone. That is called as the testing, online testing. While this, generally for testing, what we do, we stop the system, do the testing, put the new software and run the system again. But here, stopping the system doesn't happen. It is already running and some change is to be done, particularly mission critical systems, change is to be done. Therefore, online testing must be carried. Finally, changing the communication is very important. You come to know that the two objects to communicate, what is the way to communicate between them? Between Wi-Fi and Bluetooth, two different interfaces, how do you establish communication? UV link and Wi-Fi, how do you establish communication? What are the different things that we should be doing so that any two drones or any workstation and drone, they are capable of communicating with changed situation. changed communication systems is another evaluation mechanism that is being investigated and research is being carried. Of course, this is my main topic, but this is very advanced. Only I want to bring into you that dynamic evaluation of drones are required, and there are 4 different areas where evaluation is required. One is command language, which is called as syntax. Another is called as semantic evaluation, which is nothing but dealing with the firmware available on the drones, which is misbehaving. More functions are to be added. Existing software is to be corrected. All that put together has to be done dynamically, and therefore that leads to semantic evaluation. Anyway, every software must be tested online. That is evaluating the evaluation of the test process. Finally, the communication must be adopted as the newer and newer heterogeneous systems are coming around. You need to be able to communicate. And what do we do within the drones so that this dynamic evaluation of communication system can be done? These are the 4 frontier areas where research is being done. Any questions? It is open now. Any questions?
Any query, or if you have any project in your mind, so you can contact your team or
if you have any questions, you can raise now. If not, also I am your professor staying here only. You can raise some questions.
So what I observe, majority of the students just coming for the SIL attendance, and that is a very negative. When I conveyed the search profile, what I told, how many areas specializations having, why you are thinking that you are from AIDS, you are from SID, so don't make limited to yourself. Your knowledge always means the expected result. Don't attend the SIL events just to get the attendance. You can learn at least something from each and every session. Doesn't matter that who is the person who is standing here. So, all of you, why 22, and it is a very golden opportunity next 2 years for you. Utilize your each and every moment. Don't think that you have the time 3-1, 3-2, over 4. Don't be in that perception. And learn from these students also, those who are getting the education. What is the difference between you and them? So be sincere, utilize the whatever opportunity you are getting.